So we saw a D flip-flop with a synchronous reset. Now let's see how we can describe one with an asynchronous reset. So now we want a D flip-flop with a asynchronous reset. What this means is that the reset should take effect immediately. It need not be synchronized with clock. Okay, so if reset goes high, then immediately Q should become 0, irrespective of whether there was a clock edge here or not. So if I were to use the same test bench as in the previous example, but only change the behavior of my D flip-flop slightly, so that this reset input now behaves like a asynchronous reset. How could I do that? How can I do that using VHDL? That's a thing. So you can think about it. What we want is we want the reset to have immediate effect on Q. Okay, whenever the reset goes high, irrespective of whether it is on the clock edge or not, we want Q to go low. So let's see the output waveform. Here is the reset. The first thing is the reset input, and it's high, and then it goes high little later. This is the clock input. So notice that there is no unknown or X value on the output because reset is high. So when the reset is high, immediately Q goes low. Here so far up to this point, the clock edge has not arrived, but Q immediately goes to 0. And then here reset goes to low at this point. But so far the clock edge has not arrived. So here the first clock edge arrives. So at this point D was 0, and so Q remains 0. Then on the next clock edge we had D is 1, D was equal to 1, and so Q becomes 1, and so on. And now notice that here there was another pulse on the reset input, but it did not coincide with any clock edge. So this was a rising clock edge, this was a rising clock edge. This happened in middle, but still as soon as this reset went high, immediately Q went low. Okay, and then when reset was low again, it remained low until the next rising clock edge. So until this point. And then at this point we saw that D is also low, so it remains low. Then on the next edge D is 1, so it becomes 1, and so on. So this is the behavior that we desire for a flip-flop with a asynchronous reset. That means the reset should have effect immediately. So let's see how we can describe this using VHDL. So it's just a very little but very important difference. Small difference, it's very important. We want any change in R to be reflected immediately. So R should be there in the sensitivity list. Okay. So we have clock and R in the list, and R has priority. If R is 1, then Q should be 0. Else if R is 0, then we pay attention to the other conditions, that is if there is a event, if there is a rising edge on the clock, then Q is assigned the value of T. So think about how you would describe these various conditions. Either it could be a latch with a synchronous reset, a latch, well there is no synchronous reset for a latch, right? It's a level sensitive device. So a latch with a reset, or a flip-flop with a asynchronous or a synchronous reset. Further, the reset can be active high or active low. So a active high reset means if the reset value is 1, then the flip-flop is reset. And active low means if the reset value is 0, then the flip-flop is reset, otherwise it behaves as it is. So it is as if you are connecting a bubble or inverting this outside the reset pin. So this is D, Q. Similarly, if you have this symbol, it just means it's a positive edge triggered flip-flop, whereas if you have a bubble here, it means it's a negative edge triggered flip-flop. So remember these conventions. So on the little wedge, this means a positive edge triggered of the clock, whatever, if this is a clock signal. And if you have a bubble here, that means this is a negative edge triggered device. Okay. So coming to the exercise of this lab, okay. In this lab, you are asked to write a behavioral description. That means not a structural description. You have to describe the behavior using a process block, just like how we describe the D flip flop. But you have to describe a negative edge triggered T flip flop. So if you recall from our theory lectures, T flip flop is a toggle flip flop. This flip flop has a clock input and it doesn't have a data input, it has an input called T. If T is 1, then the state toggles. If T is 0, then the state remains the same. That's the behavior of the toggle flip flop, right? And it's a device, and you're asked to provide an asynchronous reset for this device. So you have to write a behavioral description, okay, and write an appropriate test bench that tests all possible cases, okay. So when the clock edge arrived, the T was 0 or T was 1, and T changed in between the clock edges, reset was 1, reset was 0, all these conditions it should test properly. And you are asked to submit 2 files. One is the single code containing both the code for the T flip flop and the test bench, and a short report which has to be a PDF file, okay, containing the interface diagram of the T flip flop, the simulation waveform that you got, demonstrating its functionality clearly, and a screenshot of the code just showing the behavioral block or the architecture of the T flip flop. So that's it for lab 7. It's a short exercise. I'll see you all for the next lab.